Hi, and welcome to Pharmacochemistry Vibes. Are you interested in studying aromatic amines? Do you want to know what is the aniline women? Also, in science, serendipity means accidental discovery. Do you want to know which is the most colorful accident in chemistry? Yes, then you are at right place. Introducing you aromatic amines. Let's have a look at what do we actually mean by aromatic amine. Like we have learned phenols, they contain hydroxy group attached to the benzene ring or aromatic ring. Aromatic amines also contains amino group directly attached to aromatic system like benzene. And similar to aliphatic amines, here also we have primary amine, secondary amine and tertiary amine. In primary amine, both hydrogens are free and nitrogen is attached to only one carbon. Whereas in secondary amine, one of the hydrogen is substituted or replaced with some group and only one hydrogen is remaining. Nitrogen is attached to two carbon atoms. In case of tertiary amine, both the hydrogens are replaced by some substitution. So nitrogen is attached to normally three carbon atoms. And compounds are also named in this way. In case of secondary amine, we write capital N to indicate which substitution is present on nitrogen. For tertiary amine, nitrogen capital N is written twice and substitution, if it is same, it is prefixed as di. We have also seen what is toluene. In case of toluene, there is a benzene ring attached with methyl group. So a compound containing amino as well as methyl substitution, that is aniline plus toluene, is called as toluidine. Depending upon their mutual positions, it can be ortho, meta and para. Mind well, in case of benzyl amine, it is not considered as aromatic amine because nitrogen is attached to a carbon which is sp3 hybridized. It is not directly attached to the aromatic ring where carbon is sp2 hybridized. So this is still considered as aliphatic amine. In this series, aniline is the most important prototype, you can say, for this series, and all are derivatives of this aniline. In the early days of discovery of aniline, we have several scientists who contributed to it. Like in 1826, Otto obtained one substance by destructive distillation of indigo and he named it as crystalline. In 1834, Friedrich Runge isolated one substance from coal tar which, when reacted with lime, turned bright blue. He named it cyanol or kyanol. In 1840, Carl Fritzsche he obtained one oily substance by treating indigo with caustic potash. He named it as aniline. Soon, in 1842, Nikolai Zinin produced one substance by reduction of nitrobenzene and he named it as benzidam. In 1853, Weissenhitz reacted the same substance with concentrated H2SO4 and potassium dichromate and observed blue color. And then we have the scientist who is known for several other contributions, August Wilhelm von Hoffman, who worked a lot on aniline as well as some other major discoveries in chemistry. He studied all these substances in detail and declared that these all are one and the same, and that is aniline. Soon after this, the name aniline was widely accepted and utilized. Sir Hoffman studied at Justus Liebig University, Gießen, Germany. Actually, he was admitted to study law in that university, but after seeing laboratories of Sir Liebig, he changed his mind and pursued chemistry for his life. Does it remind you of someone who also changed his mind and pursued chemistry after listening lecture of Sir Liebig? Do write in the comment section. So after completing the studies under Sir Liebig, Hoffman moved to London. He was offered a position of director at Royal College of Chemistry. Now this was the first of its kind which involved teaching chemistry with experimentation and more of industrial applicability. Now this college is nowadays part of Imperial College. So you can clearly read this college was modeled on Liebig Laboratory, Gießen, by Hoffman, and here Hoffman inspired the young to do great things in chemistry, and soon it came true because some students of Hoffman, of which one we are going to study in detail, they literally did miracles. In 1853, a 15-year-old boy named William Henry Perkin took admission to Royal College of Chemistry, and he was introduced to Sir Hoffman. Because of his passion, just after 1 year, Perkin assembled a laboratory at his home to carry out his independent research. By 1856, Perkin became assistant to Sir Hoffman, and Hoffman gave him a very challenging project to synthesize quinine in the lab. Till then, quinine was known to be significant active against malaria, and it was present in cinchona bark, but every time extracting it into large amounts was very much expensive. So Hoffman wanted to synthesize quinine in the lab. Perkin and Hoffman spent almost 3 years to synthesize quinine in the laboratory. In 1856, it was spring and it was Easter vacation to all the students. So it was a time when most of the college students were enjoying their vacation. Perkin was working in his lab. So Perkin was trying hard to synthesize quinine in the lab. He was experimenting with allyl toluidine, reacting it with potassium dichromate in presence of sulfuric acid. This did not produce quinine. So he wanted to change this amine, and he decided to try aniline. When he reacted aniline with now potassium dichromate in presence of sulfuric acid, again his experiment failed and he did not get quinine. But when he was washing his glassware, he observed there is a dark purple sludge, and even after washing with alcohol, there was a bright purple stain on the glass. Let me tell you, Perkin was also a painter and photographer. So the moment he saw this bright purple stain on the glass, which was not easily removable, he immediately thought about potential of this dye, because till then purple was a color of only rich people, because to obtain this purple color it was too much expensive. 10,000s of the snails needed to be killed to obtain it, or it was obtained from lichens, but it was very scarce. He thought to work with this, but because Hoffman had assigned him quinine project, he moved his setup to a hut in his garden, and then he experimented to produce this dye in the larger quantities. Aniline was obtained like other aromatic amines, it was obtained from coal tar, which was a byproduct for several other industries. So utilizing a byproduct in producing something which is hard to obtain from other natural sources? Yes, it was a grand idea. He pursued this, and within 1 year he filed a patent. He was only 18 years old at that time. He named his dye Mauven. Later on, he did inform to Hoffman about his discovery, and he actually wanted to be entrepreneur, living science and having his own production as a factory. But Hoffman denied, and Perkin pursued his research, but he kept experimenting with his friends, even his brother, and they tried to dye silk and other fabrics with this purple stain, and they even approached to several other manufacturers of the dye to fulfill their dream. This is one sample bottle in which his dye was kept. So Perkins' accidental discovery of this Mauven, it was a major breakthrough in the chemical industries, and this literally revolutionized the world of fashion because synthesizing colors became very much easy rather than extracting them from the nature, as well as that procedure was expensive and those colors were not staying on the clothes. So soon it was became very famous and it was widely accepted. After a few years, Perkin started his own company along with his friends and brothers, funded by his father. So they carried out large-scale production of this dye, which revolutionized and inspired many other industries. Since then, synthetic dyes were called as aniline dyes. Besides this discovery of Mauven, Perkin was also known for discovery of amino acids, tartaric acid, alizarin, coumarin, and many other substances. So it was a breakthrough discovery which led to foundation of several other industries. The most notable was Badische Aniline and Soda Fabric (BASF). This is still one of the largest chemical manufacturer in Germany, and they have their ventures in more than 80 countries. Most of the business of this company was related to aniline dyes. And also you can see on one of the dye label, you can see one Indian woman milking a cow, probably because India was the largest producer of indigo that time. If you visit their website and go to the section of BASF History, their slogan is "We create chemistry." So in this history section, you can read their 150 years history from 1865 till today, and they have clearly mentioned how this company was started. It was because Perkin, who coincidentally discovered first coal tar dye because aniline was obtained from coal tar. So he discovered this dye and thus it was a possibility to use coal tar as a raw material for synthetic dyes. After that, several other dyes were manufactured and this industry grew. Now coming to the interesting term, the Aniline Women. On the BSF website, you will find compilation about all the female employees right from 1865 till today. So all the female employees who served at BSF at various positions, right from the cleaning staff, then nurse, then scientist, and even in the patent department, at the leadership positions, all their contributions are compiled and they all are named as the Aniline Women because the major work of BSF was on aniline dyes. I hope you found it interesting and useful. As somebody rightly said, chemistry plays a great role in deciding rise and fall of the nations. So please share this video maximum so that it reaches to the students who do not have interest in chemistry or who find it difficult. These are some sources from which images have been taken. Do read about detailed article on discovery of this aniline dye, and you can also visit website of BSF. In the upcoming lectures, we are going to study basicity of aromatic amines, some methods of producing these aromatic amines as well as some reactions and uses of some important aromatic amines. Till then, take care. Goodbye.